Hey guys, welcome. This is our project BMI prediction using face images. Now I'm going to explain the code. First of all, these are the record libraries. We need to install those libraries first. Then we can import it. Uh, this step is used to retrieve the data from the database, which is Cassandra. That is we used. If this it was hyphenated, you can go where the second cell followed by it. This is we created on log file to save the log of each and every steps, so that we created a log file. So the next step, we import the path from pathlib. This function get index of each digit is to identify the sample faces folder. We have those images instead of the sample faces. These images we need to train. So for identifying the particular images, we use the get index of digits. So data folder is defined, sample faces or data folder. Then we started the all images. Then logging.info. This logging info is used here to save a count of the images, total images which are in the sample faces. The total we have 257 photos. It was automatically saved into the bmi.log. This is our directory. id.directory is contains all these images. The next step, we need to merge the images and UID and path. So wait. First of all, I need to show the data set. Here the data set we have the ID, UID, name, height, weight, columns. Here UID and path is merged with the UID is from the dataset and path is now we created from the sample faces from the previous functions. This function is used for my face encoding. This function is used to create a face recognition for each images. The face recognition is performed by the face recognition model. If the face is not recognized, it will print the no face found string, and also it save the warning in the BMI log. The total face image, total faces is an array. It was appending into a new image. We iterate from the images. We iterate the whole images in the sample faces folder, and it was appended into the total faces variable like this. It was saved like this and appending. Then the next step, we converting into the array format. The x equal to so you can see this is a no face found, so it also saved into the bmi.log folder. Warning, all the other logs is .info, but it was a warning. Here that we mentioned for converting the total faces into array. And the next step, we can assign the values, height, weight values into y height and y weight variables from the dataset. Splitting the dataset, the train split was imported from sklan. Then we created the test and train data. Converting data into a float, because I got an error, so I converted into float. And we need to identify our shape of input images, so I print it. This is an important step in our project. We are using the convolution neural network for face data extraction and creating the models. The model weight is used convolution. These are 1 2 3 4 layers dense, flatten, mask, pooling, and convert 1T. We used 128 neurons to dense layer, and we used the activation function that is low and optimizer is Adam, and batch size is 1, epoch is 13. You can go with another optimizers there which is very suitable for your model. You can choose it. Okay, the loss is the more accurate loss value is nearest to 0. We need to consider which has coming nearest to 0. It was very good model. The height model give the loss value 0.005, and the weight model also has same layers which was used in the previous height model development, but then we can save we saved the models in the last step of the model creation. Now to load the model, yeah, we have the two models, height and weight. Now we want to load the models. This is our function which you are going to predict our BMI and height and weight. Input image and height model and weight model is our parameter values. Login for this also created for the function. It save the path of the input image. Yeah, and also it save the output, height, weight, BMI, and runtime also. Runtime is a calculation of the function running time, start time and end time. We calculate the end time minus start time. This is runtime. And also the text array is assigned to expanding dimension of the input image. The input image was given to the myface encoding function, and NT array was used to fix the multidimensional array. Yeah, so that we use the NT array. And BMI, we know BMI formula is now available in Google. Now you got the complete model development is over. Now we are going to check our model performance, yeah, in a code level. So it gives the exact values is not because we trained only 50% image data. Okay, so we want to give more face images and data. It will give the accurate values. The Akshay height is not 1.7, but it give a nearest value to Akshay's real value. Yeah, we need to give a more data information. It will give a accurate value in output. And also the images must be clear and fixed size. So now we are going to use the GUI. Previously we seen the goal level testing. Now we choose the browse. We choose the images by clicking the browse. Yeah, then previous we choose the Akshay in portrait. Now we choose the images in a landscape 1.75. I think it was exact. It's a very nearest to the Akshay data. Height is 1.75, weight I think 80, but it give the 79. Yeah guys, now we are going to use the capture option. By clicking a caption, this is me, but I didn't give my face in sample faces. It was not trained, but it give the exact height of my height. My height is 1.71 meter, but it gives the correct height, but weight it's not 73. Thank you.